This is the homework help video for Math 3 Unit 2 Worksheet 1, and I'm going to do questions number 2 and 4. So for question number 2, they ask you to find the open intervals. So open intervals means we're going to have parentheses, regardless if it's a solid dot or not. And then for which f is increasing. So whenever we see the word increasing, we need to be thinking as we go from left to right, we're going uphill regardless of the way the arrows are pointing. So I need to be thinking, something that is going uphill. And so as I trace my graph from left to right, I'm going downhill. And then when I start right here, I'm going uphill. So the section I'm increasing is this section right here. And when I state the interval, I do it along the values of x, not the values of y. So I'm only looking along the x-axis. So I'm starting at x equals 1. And I'm going to stop right here. So I'm going to draw down to see where is that value at. So that's at 1, 2, 3. So from x equals 1 to x equals 3. So from 1 to 3, I'm going uphill. And then for part B, it says to state the open intervals on which f is decreasing. So again, open intervals means I'm going to do parentheses. And then for the decreasing, then I'm looking for where am I going downhill. And again, I'll be referring to the x values. So as I move from left to right, I'm looking for values where I'm going downhill regardless of the way the arrows point. So for this section here, I'm going downhill, and I'm also going downhill on this piece right here. So downhill and downhill. So on this first section, I'm going to drop to the x because I'm always looking for where are my x values. So I'm going to count out to here. So that's starting at -6 until I get to +1. So the first section is from -6 to +1. There's another section, so I'm going to use the union symbol. And that second section is starting here. So that was at 1, 2, 3. And then the arrow meaning towards the right, so decreasing to the right forever. So don't be fooled by the down arrow meaning -infinity, because remember it takes on 2 directions, so it's going down and to the right, but we're doing x-axis, so it would go to +infinity to the right. Okay, so then that would be starting at 3 and then going until +infinity. Okay, so domain and range. So we have to label our 4 corners. So we already have this arrow is giving us 2 directions, to the right and down. And then there's no other arrows, so that means there's a farthest left, which I already found was -6. And that must mean there's a farthest up, which is this point right here. So now I'm going to count for this corner, so that would be at 7. So domain is left to right, and it's a solid dot at -6. So that gets a bracket, and then comma right, and parentheses on infinities. And then for my range, bottom comma top, so -infinity until I get to 7. And that's part of the graph, so that would be a bracket. So maxes and mins are the next, and I want to do coordinates, so that means I want to do ordered pairs, so x and y. So I have to give an x and a y value. A minimum is when I go from decreasing to increasing, so I'm looking for something that looks like that. Could be rounded or sharp. And so I'm going from decreasing to increasing, so right here. So then I need to find that ordered pair. So on the x-axis, that's at 1. And on the y is at -1. So this is an x and a y value. And then for my coordinates, so again I need an x and a y value. and my relative max, so I'm looking for where I'm going from increasing to decreasing. So the only section I see where I'm going from increasing to decreasing is right there. So I need an x and a y value. So my x value is at 1, 2, 3. So my x is at 3. And then my y was at 7. So now for the two-piece function, I have to give an equation. So I have to recognize that this is linear and this is quadratic. So I'm going to do the linear first. So my basic equation, and then I need to find 2 points to substitute x and y and h and k. So for linear, there is no vertex, so I can pick either point to be my xy and either point to be my hk. So I'm going to just choose this one to be my hk. So that was at -6 and +6, so that's my h and my k. And then this one I'll call my xy, so that was at 1, -1 for xy. Okay. So then I just need to replace the values except for the slope and then solve. So I'm looking here, my y value is -1, my k is 6, I don't know m, my x value is +1, and my h is -6. But then that double negative turns positive. And then I just want to solve, so that's -7. And then 6 plus 1 is 7, but I don't want to write it as m7. So that would be 7m. And then to solve for m, I would divide by 7. Okay. So then my equation, so now that I have my slope, I'm going to write it in the form here, the y minus k form. So that would be y, and then my k value, so I'm looking up at the top here. So my k is 6, so y minus 6 equals m, and then x minus h, but a double negative is a positive. Okay. And then I want it into that y equals form, so I'm going to add 6 over to the other side. So there's one equation. And then I want to do this again, but I want to do it for the quadratic piece. So I'm going to do that over here. So there's my formula. So my vertex is my hk. So this is the vertex of the parabola. So this point right here, which was my maximum, right? So my max was 3, 7. So I know that for my parabola, that ordered pair is my h and my k because it's the vertex. And then I just need any other point to be xy. And so this point where the line and the parabola connected is good for the line, which I use for xy, and it's also good for the quadratic as my xy. So I replace y with -1 and k with 7, and replace x with +1 and then h with 3. And then solve for a. So -1 minus 7 is -8, and then 1 minus 3 is -2. And then squared is +4, so I'm going to write it as 4a. And then divide by 4. So a is -2. And then I'm using the hk up here again. So this is my hk for my quadratic. And replace the values in here except for x and y. So it would be y minus k equals a, and then x minus h squared. So I'm using h and k and h and k. And then write it into the y equals form. So I'm going to add 7 to the other side. and there's my quadratic. Okay. So now all I have done at this point is come up with the equations that represent a line that would go forever, and then the parabola that would go forever. And so I have to restrict the domain. So then I'm going to do that off to the side here. So then for my pieced function, I'm going to start with my linear. And remember, I don't need to write the y equals part. I just need to write the right-hand side. And then the same for the quadratic. And then I have to do what is my restriction. And so this is helpful to look up at my increasing and decreasing since I've already done that portion. So I said that this part was decreasing from -6 to 1. So on the x-axis from -6 to 1 I was decreasing. And that's also the same domain as my restricted line. So my line does not go beyond -6 or 1. So then I'm going from -6 to 1. So this is my restricted domain. And then for my quadratic, I'm starting at the x equals 1 and then tracing forever because of the arrow. But remember, it's the x value, so I'm starting at 1 and I'm going to infinity. And I don't want to double count the 1, so even though it was bracketed here, I'm going to parentheses here. And so from 1 to positive infinity. So don't get confused that because you see this down arrow, you're thinking negative infinity. Remember, that arrow takes on two directions, down and to the right. Okay, and then let's take a look at number 4. So for number 4, I'm just going to do part G because that's the hardest portion. So for 4G, I need to do 3 graphs. So I'm going to start with my quadratic. So I'm going to go from left to right. So this is my quad. And so that equation. And then my HK is my vertex, so that would be 1 and 2. And then I can use any point. So they have this point marked, so I can use that, or I can use the origin 0, 0. So I'm going to use 0, 0 just because working with zeros is a lot simpler. But again, I can use the 2, 0 and still get the same answer. So I'm going to replace y with 0 and k with 2. And I don't know a. And then I'm going to replace x with 0 and h with 1. So 0 minus 2. And then negative 1 squared is positive 1, so this is the same as 1a. And so a equals negative 2. And then write your equation, so it's going to replace the k, a, and h, but leave x as x and y as y. So we're looking up here. So h and k are 1 and 2. So y minus k equals a, and then x minus h squared, and then solve for y. So then add 2 to the other side. And then for the linear, so this is the formula, so you do have to have those equations memorized, right? So y minus k equals m times x minus h. And again, I could pick either point for hk because lines don't have a vertex. So I'm just going to choose 3, 3 as my hk and then 2, 0 as my xy. So if you chose it different, it just means your equation will look a little different. Doesn't mean it's wrong though. So replace y with 0 and replace k with 3, and we don't know m. And then replace x with 2 and h with 3. So that's negative 3 And then 2 minus 3 is -1, so -1m. And then divide. So m equals +3. So now your slope should be the same, it's just that your h and your k might be different if you chose the other point. And again, it doesn't make it wrong. It's still the same exact equation. So I'm going to use the 3 and the 3 up here for my h and my k. So my equation is y minus 3 equals m and then x minus h, which was 3. And then solve for y, so I'm going to add the 3 over. Okay. And then the last equation right here, this is just a special case, right? So this is a special case because it's horizontal. So for the special case, I just need to know if I were to extend it, does it cross my x-axis or my y-axis? And it crosses my y, and then it crosses at 3. So each grid was worth a half, right? So to get from 2 to 4, we're counting 2 squares, so 3 and then 4. So this is at 3. And if I look here, my y values are 3. So for the special case graphs, I'm just going to call it special. It's just y equals 3 because it crosses the y-axis at 3. So it's a special case or a constant. And then for my equation, so I'm a little bit tight for room, so I'm going to squeeze it in here. So I'm going to start with my quadratic. So again, we're just writing the right-hand side of the quadratic. And then my linear. And then my special case. So those are my 3 equations, and now I have to do their domains. So we're just looking, where do they start, where do they stop? So let's start with the parabola. And again, we're doing values of x, so it starts at x equals 0, and it stops at x equals 2. So from 0 to 2 on the x, and they're both closed dots, so from 0 to 2. And then for the linear, so let's jump back here, so to the linear. Again, we're looking at x values only, so from x equals 2 to x equals 3. So from 2 to 3. So from 2 to 3, I have my linear. And I don't want to double count the 2, so I'm going to do parentheses on this 2, and then close on the 3. And then for the special case, again, we're looking at x values. So it starts at x equals 3, and it ends at x equals 5. So from 3 to 5. And then I don't want to double count the 3. And from 3 to 5. Okay, and that's the homework help video for objective 1.